Hello everyone, welcome to my presentation. My name is Minka. I am a master degree student from Electrical Engineering Department, Chulalongkorn University. Today I'm going to talk about Bornholm Island Microgrid located in Denmark. Outline of my presentation include introduction, ownership, location, investment, capacity and components of microgrid, driving forces, design concepts, research, further research and development, and references. Bornholm Island Microgrid is the energy system with 28,000 customers with a peak load of 55 megawatts. It is 100% renewable based electricity and heating system. It is the equivalent to 1% of Denmark with regard to area, population, and energy consumption. There are distributed energy resources such as wind power, solar PV, combined heat and power, electric vehicles, biogas, and district heating. Bornholm Island can do islanding operation capability, so it can totally separate it from mainland. It has the integration with Intelligence Control Center Lab at Technical University of Denmark. It is the unique facility for experiments with new smart grid technologies. Auskraft Company is the main distribution system operator of Bornholm Island Microgrid. Bornholm Island Microgrid is the part of the Nordic Interconnected Power System and power market. It is also part of the experimental platform for Power Lab DK. It is the Electric Power and Energy Lab under the Danish Energy Agencies, part of the Danish Ministry of Climate, Energy and Buildings. It supports technology development, testing, training and demonstrations that contribute to the development of a reliable, cost-efficient, and sustainable energy system based on renewable energy sources. Bornholm Island is located 169 km southeast of Denmark and 35 km south of Sweden, so it is closer to Sweden than Denmark. The area of the island is about 588 km square. It has the population of 41,000 people. Bornholm Island has been a platform for the development, testing and demonstration of innovative green energy technologies for more than 10 years. It has handled projects worth more than 100 million euros. Danish universities and companies such as Danfoss, Siemens and IBM use Bornholm as a test island for microgrid system. For capacity, Bornholm Island Microgrid has 37 MW of combined heat and power steam turbine, 30 MW wind turbines, 5 MW solar PV system, 2 MW of gas engines which use biogas as fuel, 34 MW backup diesel generators, 25 MW backup steam turbine, and electric vehicles can also be included in generation. Bornholm Island Microgrid has about 28,000 customers. Among those customers, there are about 300 customers who use more than 100,000 kWh per year. It has total energy consumption of 250 GWh per year and annual peak load is about 55 MW. Fiber network communication is used between 60 kV and 10 kV substations. This fiber network communication covers about 131 km. Microgrid has district heating systems. There are 5 district heating systems and total heat demand in 2007 was 560 GWh. There are 131 km long 60 kV power grid, 927 km 10 kV power grid and 1913 km 0.4 kV power grid. Inside the microgrid, there are 60 kV to 10 kV substations and 1039 10 kV to 0.4 kV substations. Driving force of Bornholm Island microgrid is to become Green Island. The Bright Green Island vision has 4 cornerstones: sustainable business, good living, smart island, and green destination. Sustainable business include energy source, green construction, and local innovation. In good living category, green education, sustainable society, and local food are included. Bornholm Island will be smarter if it becomes test island for green energy and clean technology. From tourism point of view, the island must have green solution houses and sustainable nature to be a green destination for tourists. Bornholm Island has 3 main networks: 60 kV, 10 kV, and 0.4 kV. The 60 kV side of the transformer in a Sweden substation is connected to the 60 kV substation at Bornholm Island by the overhead cables. The control room can control tap changers and capacitor banks in 60 kV and 10 kV substations. During island operation, the sharing of wind power is necessary to avoid unwanted power oscillation in the system. For research activities, there are several research can be done at Bornholm Island microgrid. The research activities are divided into 5 main subjects: demand response and market, island operation, wind power integration, experimental research platform, and transportation. The objective of the research is to develop a smarter low carbon emission electric power system which can handle an increased share of renewable energy and distributed generation to enable an open market and secure the reliability of supply. A research paper presents the use case of microgrid as DC microgrid. High-power EV chargers could cause significant overloading in the distribution grid. This influence can be minimized by integrating EV chargers with BESS. Design of DC microgrid involves a PV system, bus, a wind turbine, and EV bus charger. The microgrid has a 30 kV connection to the 0.4 kV AC grid. The AC and DC sides are connected by 3-phase 0.4 kV AC to 0.62 kV DC converter. The operation principles of DC microgrid are to ensure that the power production from PV and wind turbine is used to charge EVs and to inject into the AC grid with a controllable power level. Other use case is as a virtual power plant. The objective is to demonstrate how different distributed energy resources, biogas, wind, solar, EVs, and heat storages can be interlinked in order to reduce carbon emission at the island of Bornholm. The single line diagram of virtual power plant can be seen in this diagram. In Bornholm Island, following future research and development can be carried out: development of new electric power market, utilization of energy storage for system balancing and services, virtual power plant implementations, and modern communication solutions for power systems. These are the references used in my presentation. This is the end of my presentation, and thanks for watching.